Our solar system is an amazing place. One of its coolest planets is Uranus, the seventh planet from the Sun. Uranus is a big ball of ice covered in a thick blanket of hydrogen and helium gas. It's a light blue color and spins on its side, kind of like a tilted toy top. Because of this, Uranus has really weird seasons. Each pole gets decades of sunlight and then decades of darkness. Uranus also has a bunch of moons, 27 that we know of, going around it. One of these moons is super mysterious and its name is Umbriel. Imagine a place super far away, where the sun looks like a tiny speck. That's Uranus, a giant planet wrapped in a light blue haze. Around Uranus are its moons, all held close by the planet's gravity. One of these moons, Umbriel, is especially interesting. An English astronomer named William Lassell found it in 1851. It's the third biggest of Uranus's moons. Umbriel is a world covered in shadows. Its surface is one of the darkest in the solar system. Because it doesn't reflect much light, Umbriel looks dark and mysterious. It's hard to see even with powerful telescopes. But Umbriel can teach us about the early solar system and how the area around Uranus formed. Scientists think Umbriel's dark surface is made of water ice mixed with darker stuff, like carbon or rocks. Figuring out what Umbriel's surface is made of can help us understand how it formed and changed over time. It was 1851, a time when astronomers were making lots of discoveries. William Lassell, who used to make beer but loved astronomy, found something amazing. On October 24th, while looking at Uranus, he saw a faint light nearby. He quickly realized it wasn't a star, but a new moon going around Uranus. He had discovered Umbriel. William Lassell's observatory wasn't just a place for science. It was where he explored his love of space. Out in the English countryside, he had a giant telescope, one of the biggest at the time. It was called the Leviathan of Parsonstown. Lassell spent hours looking at the sky with his Leviathan, carefully writing down what he saw. Like a giant eye looking into space, it revealed a brand new world, Umbriel. Finding Umbriel was a big deal. A few decades before, finding Uranus itself had changed what we knew about the solar system. Finding Umbriel and other moons around Uranus showed that it wasn't alone out there. These moons, like dancers in space, move around Uranus in careful paths, pulled by gravity. From Umbriel, Uranus would look like a giant pale blue disk in the sky, with its faint rings barely visible. Umbriel is a world of dim light and soft shadows. It's always twilight there. Its surface is one of the darkest in our solar system, meaning it doesn't reflect much sunlight. Other moons shine brightly, but Umbriel soaks up most of the light that hits it. This makes it look almost like a ghost in telescope pictures. Scientists say Umbriel's albedo is just 0.16. That means it only reflects about 16% of the sunlight it gets. Umbriel's surface is covered in craters from billions of years of impacts. Imagine a place with tons of craters, some small and round, others huge and complicated, with rims like mountains. One big crater is called Wunda, named after a dark spirit in Australian Aboriginal stories. Wunda is about 131 kilometers across, and its floor is covered in a strange bright material, probably water ice. This bright material stands out against the dark surface and makes scientists think that something hitting Umbriel might have dug up material from under the surface. Umbriel's dark, cratered surface tells us it's made of old stuff, not changed much over time. Scientists think Umbriel is mostly water ice, which is common in the outer solar system. But because it's so dark, there must be other darker stuff mixed in. This could be carbon compounds, like tholins, which are made when sunlight reacts with gases like methane. Because of its size and how dense it is, scientists think Umbriel might have different layers inside, like an onion. Umbriel is stuck in orbit around Uranus, moving slowly around the giant planet. It takes Umbriel about 4 Earth days to go all the way around Uranus. It moves at about 15,000 kilometers per hour. Umbriel's orbit is almost a perfect circle, just a little bit stretched out. Like most of Uranus's big moons, Umbriel is tidally locked. That means the same side always faces Uranus, like the moon does with Earth. This happens because of gravity. Umbriel's surface is super old, like a record of billions of years of history. It's covered in craters, showing that it's been hit by asteroids, comets, and other space rocks for a long, long time. Craters of all sizes are everywhere, from small dents to huge basins hundreds of kilometers wide. Each crater tells a story of something crashing into Umbriel. Because Umbriel hasn't changed much, its surface gives us a look back at the early solar system. Craters aren't just holes, they're clues about a planet's past. By looking at the size, shape, and location of craters, scientists can figure out when things hit and learn about the early solar system. Umbriel, with its many craters, has lots of these clues. Big impacts make complex craters with central peaks, terraced rims, and sometimes even rings. Umbriel's biggest craters, like Wunder and Skind, show these complex shapes. On Umbriel's dark surface, one thing stands out: Wunder crater. Named after a dark spirit in Australian Aboriginal stories, Wunder is a big crater, about 131 kilometers across, near Umbriel's equator. What's special about Wunder is its bright floor, which is really different from the rest of the moon. Scientists think the impact that made Wunder might have dug up brighter ice or other material from under the surface. When this melted material cooled down, it made the bright floor we see today. Besides craters, Umbriel has strange bright V-shapes called chevrons near its equator. Voyager 2 saw these, and scientists have been puzzled ever since. We don't know for sure what they are. Maybe they were made by stuff thrown out during big impacts. The V-shape could be because of how Umbriel rotates. Or maybe the chevrons are from cracks in Umbriel's crust, letting material from inside leak out and get brighter in space. We need more research to find out. Umbriel looks old and beat up, but there are hints that things might have happened inside it long ago. There are some signs of resurfacing or tectonic activity, though it's not as obvious as on some other moons. We see lines called graben, which are like ditches where the crust has dropped down. This suggests Umbriel's crust might have stretched sometime in the past, maybe because of tidal heating or the inside freezing and expanding. There's also something that looks like a cryovolcano flow, where icy material might have erupted onto the surface. This isn't certain, but it suggests Umbriel might have been warm inside at some point. Our best look at Umbriel came from Voyager 2. In January 1986, Voyager 2 flew past Uranus, the only spacecraft to ever visit. As Voyager 2 zipped past Umbriel, about 325,000 kilometers away, its cameras took detailed pictures, showing us the dark, cratered surface and hints of its complicated past. This short visit taught us a lot. The pictures Voyager 2 sent back showed us Umbriel's surface in detail for the first time. We saw lots of craters, some huge, showing how much it's been hit over billions of years. Voyager 2 also measured Umbriel's composition, temperature, and magnetic environment. This helped us learn that Umbriel is probably mostly water ice mixed with darker stuff like carbon or rocks. Even though no spacecraft has been back to Umbriel since Voyager 2, astronomers still study it using powerful telescopes on Earth and in space. These telescopes let scientists look at Umbriel in different kinds of light, learning about its surface and temperature in ways we can't see with our eyes. One important tool is spectroscopy, which looks at the light reflected from Umbriel. By separating the light into different wavelengths, astronomers can find specific molecules and compounds telling us what Umbriel's surface is made of. This has confirmed that there's water ice on Umbriel and also darker stuff like carbon compounds, which make it so dark. Spectroscopy, which studies how light interacts with matter, helps astronomers learn about distant worlds like Umbriel. By looking at the light reflected from Umbriel, scientists can identify specific molecules and compounds, learning about its composition and how it formed. One key finding is the presence of water ice, which is common on icy bodies in the outer solar system. Water ice absorbs certain wavelengths of light, creating dips in the spectrum of light reflected from Umbriel. The deeper these dips, the more water ice there is. Spectroscopy also shows darker materials on Umbriel, which contribute to its low reflectivity. These are likely carbon-based compounds like tholins, formed when sunlight interacts with molecules like methane. Voyager 2 taught us a lot about Umbriel, but we still have many questions. We need a mission just to study Umbriel. Imagine a spacecraft with advanced instruments, orbiting Umbriel for months or even years, mapping its surface, analyzing its composition, and looking inside. This could answer so many questions. What exactly is that dark stuff on the surface? Does Umbriel have an ocean under the ice? What has happened on Umbriel over billions of years? A mission to Umbriel would teach us not just about this moon, but about all the icy moons in the outer solar system. Umbriel's old surface and possible signs of past activity could hold clues about the early solar system. We need to go back to Umbriel. This enigmatic moon of Uranus holds many secrets that we have yet to uncover. Our previous missions have only scratched the surface of what lies beneath. Voyager 2's quick visit in 1986 wasn't enough. It provided us with a fleeting glimpse, but left us with more questions than answers. The brief flyby gave us tantalizing hints of Umbriel's mysteries. The Uranian System, with its unusual setup and interesting moons, needs more exploration. Each moon has its own story, and Umbriel, with its dark surface and mysterious features, is particularly intriguing. A mission to Uranus and its moons, focusing on Umbriel, is the next step. This mission would not only deepen our understanding of Umbriel, but also provide insights into the entire Uranian system. Imagine a spacecraft with advanced instruments traveling to distant Uranus. Equipped with the latest technology, it would be capable of conducting detailed studies and sending back high-resolution data. Orbiting Uranus and flying close to its moons would give us an amazing chance to study Umbriel, revealing its hidden features and history. This close encounter would allow us to observe geological activity and surface composition in unprecedented detail. A key goal would be to map Umbriel's surface in high resolution, seeing details Voyager 2 missed. High-resolution mapping would uncover the moon's topography, revealing craters, valleys, and possibly even signs of past tectonic activity. This map would show us all the craters, teaching us about impacts in the outer solar system. By studying these craters, we can learn about the history of collisions and the environment in which Umbriel has existed for billions of years. It would also help us study what Umbriel is made of, looking for clues about how it formed and changed. Understanding its composition could reveal the processes that shaped not only Umbriel, but also other icy moons in the outer solar system. A mission to Umbriel could lead to amazing discoveries, changing what we know about this moon and the whole Uranian system. We might find something totally unexpected. One exciting possibility is an ocean under Umbriel's ice. We don't know for sure, But some scientists think Umbriel's inside might have been warm enough to melt some ice and make a hidden ocean. A future spacecraft could look for this ocean by studying Umbriel's gravity and internal structure. We might also find evidence of past or present geological activity. Even though Umbriel looks old, there are hints that things might have happened there. A future mission could look for cryovolcanoes, tectonic activity, or other changes to the surface. Our exploration of Umbriel has just begun, but we've already seen a strange and beautiful world. This moon, shrouded in darkness, holds many secrets waiting to be uncovered. As we delve deeper into its mysteries, we are constantly reminded of the vastness and complexity of our solar system. Each new discovery on Umbriel adds a piece to the puzzle of our cosmic neighborhood. From its discovery in 1851 to Voyager 2's quick visit, Umbriel has surprised us and made us wonder about the outer solar system. The early astronomers who first spotted this distant moon could hardly have imagined the detailed images and data we now have. Voyager 2's flyby provided a tantalizing glimpse, sparking curiosity and a desire for more in-depth exploration. This dim world, circling Uranus, reminds us that even far away, there are amazing things to discover. Umbriel's orbit around Uranus places it in a unique position, offering us a chance to study not just the moon itself, but also its interactions with its parent planet and other moons. The dance of these celestial bodies is a spectacle of cosmic mechanics. Umbriel's dark, cratered surface shows how much it's been hit by space rocks over billions of years. Each impact has left its mark, creating a rugged landscape that tells the story of the moon's violent past. The craters vary in size and age, providing a timeline of events that have shaped Umbriel's surface. Each crater tells a story of cosmic crashes and the forces that shaped our solar system. By studying these craters, scientists can learn about the history of impacts in the outer solar system and the materials that make up Umbriel. These insights help us understand the processes that have influenced not just Umbriel, but other moons and planets as well. The bright area of Wunder crater suggests there might be ice hidden below and shows how complex impacts can be. This bright spot stands out against the dark surface, hinting at the presence of subsurface materials that could provide clues about the moon's composition and history. The possibility of ice raises questions about the potential for past or present geological activity. The mysterious chevrons, which we still don't understand, remind us that we have much more to learn about Umbriel. These enigmatic features challenge our current understanding and invite further investigation. What processes could have created such patterns? Are they unique to Umbriel, or can similar features be found elsewhere in the solar system? These strange features, and the hints of past activity, make us want to send a mission to explore Umbriel's secrets. A dedicated mission could provide the detailed observations and data needed to answer the many questions that Umbriel poses. As we plan for future exploration, we are driven by the desire to uncover the unknown and expand our knowledge of the universe. Studying Umbriel, even though it's just one moon, can teach us about the whole universe. This small, distant world holds secrets that could unlock the mysteries of planetary formation and evolution. By examining its surface and composition, we gain insights into the processes that shaped not only Umbriel, but also other celestial bodies in our solar system. By exploring different worlds in our solar system, we learn about how planets form and change, and maybe even about life beyond Earth. Each mission, whether it's a rover on Mars or a probe flying past a distant moon, adds a piece to the puzzle of our cosmic origins. These explorations help us understand the dynamic and ever-changing nature of planetary environments. Umbriel's old surface might hold clues about the early solar system when the planets were forming. The craters and geological features on its surface are like a time capsule, preserving the history of our solar system's infancy. By studying these ancient landscapes, scientists can reconstruct the events that led to the formation of planets and moons. Its dark, carbon-rich materials could teach us about the early chemistry of the solar system, maybe even about the origins of life. These materials are remnants of the primordial soup from which our solar system emerged. Understanding their composition and distribution can provide clues about the chemical processes that occurred during the early stages of planetary formation. The possibility of an ocean under Umbriel's ice is very exciting. Such an ocean could be a potential habitat for life, offering a stable environment where life could thrive. The presence of liquid water beneath the icy crust would have profound implications for our understanding of where life can exist in the universe. If it exists, it would be another place in our solar system where life might be possible. This discovery would expand the habitable zone beyond Earth, suggesting that life could be more common in the universe than previously thought. It would also guide future missions in the search for extraterrestrial life. As we continue to explore Umbriel, we're on a journey of discovery that goes beyond just one moon. Each new finding adds to our collective knowledge and brings us closer to understanding the broader cosmos. The data collected from these missions not only enriches our scientific understanding, but also fuels our imagination and curiosity. We're looking into the past, trying to understand our place in the universe. By studying celestial bodies like Umbriel, we piece together the history of our solar system and our own origins. This quest for knowledge connects us to the cosmos and helps us appreciate the vastness and complexity of the universe. And that inspires us to keep exploring the wonders of space. The more we learn, the more we realize how much there is yet to discover. This endless pursuit of knowledge drives humanity to push the boundaries of exploration and to seek answers to the fundamental questions about our existence and the universe.